So I'm going to go through one more example just to demonstrate how we might use these functions. So here's our problem. It says the relationship between between altitude, pressure, and boiling temperatures is shown. So I'm going to have to do some sort of calculations. It tells me my units I'm working in. And then it says write a function named altitude that calculates the pressure and temperature using these equations. And here's my function. One input and then no outputs. So use your function to calculate pressure and temperature for heights from 0 to 5 to the height. So to the input height. Max in increments of 500. So that means that I'm going to be doing 0 to 500 to h max. That's fine. It's just a vector. So that means I'm going to be needing to do element by element operations. Because my height is a vector. Then it says save your results in a file named pt_imp.txt, where the first column is height, the second column is pressure, and third column is temperature. So essentially, this is the results that I'm going to save. So I need the save function. Given the following conversions, convert each column to the corresponding SI units. So once again, more calculations. And then save your result in a file named pi_si.txt. So once again, save function. So save, use my save function. Same thing, height is now in different units, pressure is in different units, and temperature is in different units. And then lastly, I'm going to display my results in a table using disp and fprintf. Okay, so let's go ahead and begin. So first things first, creating my function. So when you create a function, you type function, and then the name or the outputs. There's no outputs. So then the name, altitude, and then my inputs, h_max. I can name it whatever I want. And then goes my comments. So I already have these written out. I'm going to copy paste them. So my function calculates the pressure and boiling temperature given the altitude. Its use case looks like this. Inputs, Hmax, the maximum desired height or altitude in feet. Outputs, there's no explicit outputs, but there are 2 file outputs. So I inserted those there, and then I my end. Okay, now I can do my calculations. So my height, I'm gonna say h_ft because I know I'm gonna be working with units. Equals 0, 500, Hmax. And I know that's in feet. I can calculate my pressure in inches of mercury, and then calculate my temperature as well using my equations. Okay, there we go. So now I want to save these results. So before I save my results though, I'm going to create a new variable that combines them all. So right now h is a row, p is a row, t is a row. I'm going to create a new variable called imp results, whatever you want to call it. It's a new array where I want my height to be my first column, my pressure to be my second column, and then my temperature to be my third column. Now I can go ahead and save them. So I type save because that's my function. The name of my file, it tells me in my document, it should be pt_imp.txt. The variable I want to save in there is imp_results. And then it's a .txt file, so I need this third option, that's ASCII, or ASCII, -ASCII. There we go. I have my calculations. I've combined all of my data into one variable, and then I've saved it. So if I test my function, so let me save it. Hold on one second. My answer is also named altitude. There we go. Now let me save it. So I've saved it. Now I can go ahead and test it. Altitude, let's say, I don't know, 5,000 feet. my current folder should have PIIMP, where it's from 0 to 5,000. It contains my pressure and my temperature. Okay, so I've done that. Let me go ahead and convert from feet to meters, inches of mercury to kilopascals, and temperature from Fahrenheit to Celsius. So I've done all those calculations. Now I'm going to go ahead and save those results in a different file called PTSI. Same thing. I need to combine all of my data into one variable. So SI results equals H underscore M as a column, next to P, KP, A as a column, and then T, OC as a column. Now I can do the save function. The name of my file is pt underscore si.txt. The name of my variable is si results. And then once again, it's a .txt file, so I need the ASCII. Save that. Now I can test my function again. So now in my current folder, I have PI imperial and PTSI. So here's my units in feet, inches of mercury, and degrees Celsius, or degrees Fahrenheit. Here it is in meters, kilopascals, and degrees Celsius. Okay. The last thing my document tells me to do is to display my results with both disp and fprintf. So if this is what I want my table to look like, using disp, I'm going to print out my first header line and my second header line. So it looks like this: disp height. I don't know what spacing is yet, so I'm just gonna choose something. Pressure, boiling temp, disp. I can't align my units though. I just don't know where my numbers are going to be. Whenever you're printing out numbers with disp, I encourage you to type format short G just to make sure that they are displayed with about 4 digits past decimal point, and then you don't have that 1 times 10 to the 3 that shows up all the time at the top if they have a wide range of values. And then I'm just going to print out my data where it's in columns, which turns out is my SI results. There we go. So SI results contains my height as the first column, my pressure as the second column, and my temperature as the third column. So I'm just going to display that variable. Why recreate it? Okay, there we go. This is what my table looks like. Notice my header file or my header lines aren't lined up, so I'm just going to line them up. I'm going to move height over 1, 2, 3, 4, 5. Move that over 5. Test it again. Okay, so height's lined up. Line up pressure 1, 2, 3, 1, 2, 3. Yeah, that's lined up, and boiling temperature is over 1 extra. There we go. Just manually space it. That's using disp. With fprintf, we have a little bit more control. So I'm going to add this to indicate we've used the disp function to print out that. So let's do the same thing with fprintf. So same thing with fprintf, I'm going to print out my 2 header lines, just manually. Height, pressure, boiling temp. \n. So with fprintf, we need to insert the \n manually. Height, meters, kPa, degrees Celsius, \n. There we go. There's my 2 header lines. Now with fprintf, to print out my numbers as a table, I need to figure out how I want each row to appear. So I know I'm going to put a number next to a number next to a number. So here is essentially, I can use this as a template. A number next to a number next to a number. My first number, my first column, I want to have 2 digits past the decimal point, or maybe 3. We'll do 3. We'll do 3 for all of them. We'll do 3 digits past the decimal point for all of them. And then my width, play around with it. How wide do you want it to be? You can start out with everything at 10 and see how that lines up. We'll just do everything for 10. Okay, and then \n. And now I need my data to be in rows. So it's SI results transposed. So for disp, they're in columns. For fprintf, they're in rows. So now I run it. Whoops. Now I test my function. And here it is with fprintf. That's pretty good. I'm not going to lie. I'm pretty happy with that. Let's line up my header. So 1, 2, 3, 4, 1, 2, 3, 4. See where that goes. Okay, so height is lined up. That's good. Pressure can be over 1 more. That's good. Boiling temp. Okay, so I don't want my values to be back. I don't want to bring them back. I want my numbers to be pushed out more. So I'm just going to increase the width. I want the width to be increased by 3, so I'll just do 13. So now my numbers were pushed out versus having to manually space everything here. Okay, so there's 3 in between height and pressure, 2 in between boiling point. Let's say I just want to backspace 1, decrease this to 9. Try it again. There we go. So now they're just nicely evenly spaced. So now we can see, let me make this big. This is what it looks like with disp, where we don't have control over how the columns appear per se, other than using format short G. I have no control over how much space it takes to print between numbers, whereas with fprintf, I have more control over everything. And there we go. There's finishing up this this problem, where you can see that even though our function doesn't necessarily return anything explicitly, it's still technically returning data into a text file or into text files, and then also displaying something to the screen. So there's not explicit return, but there is implicit return in our function.